So for 310, we're going to be talking about how to use slopes in all of this and distances to find out if shapes are what kind of polygons they are. So just recall the formula for finding slope is y2 minus y1 over x2 minus x1. So if I wanted to know that this was a rectangle, well, what I would have to do is I'd have to find the slope of all of these pieces, and I'd have to prove that the slope of this line and this line were the same. I'd have to prove the slope of this line and this line were the same, and then I'd have to prove that their slopes were opposite reciprocals, or they were flipped and switched. So to find the slope of AD, well, I would have to go up 1, 2, 3, 4, and over 2. So the slope here would be 4 over 2, and it is negative because I went left. For B to C, I would have to go up 1, 2, 3, 4, and over 2. So again, the slope is 4 over negative 2. Now I've got to find the slope of the other one. Well, to get from A to B, I have to go up 1, 2, 3, 4. 1, 2, and then, so I'm going up 4 and over 1, 2, 3, 4, 5, 6, 7, 8. And that would be positive. And then from D to C, I would go up 1, 2, 3, 4, and over 1, 2, 3, 4, 5, 6, 7, 8. So again, the slope is 4 over 8. Well, if I reduce all of these, 4 divided by negative 2 is just negative 2. 4 over 8 is positive 1/2. And so the question we have to decide is, are these slopes opposite reciprocals? Well, opposite reciprocals would be that one is negative, one is positive, and the other one is, they're flipped versions of one another, and that's going to be true in this case. So yes, this is a rectangle. So it says, describe how you would use the slope. Well, if I want to prove that this is a right triangle, I have to prove that this is a right angle, that these two lines are perpendicular. So it's the same thing. I've got to find my slope. So my rise is 3, my run is 3, and that's positive, and 3 over 3 is 1. And to get from B to C, my rise is 1, 2, 3, 4, 5, 6, 7. And my run is 1, 2, 3, 4, 5, 6, 7, and it's to the left, so it's a negative 7. 7 over negative 7 is positive 1, or negative 1. And these two are, in fact, opposite reciprocals, so this is a right triangle. So another thing that can help us is our distance formula. So remember, the distance formula is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So we could use the distance formula to describe that this was a right triangle, and we can do that by finding this distance, and finding this distance, and finding this distance, and then we can use the Pythagorean theorem. Now, we've already proven that this is a right triangle, so we're not going to actually do that. But if this is a right triangle, then what should happen is that whatever a squared is plus whatever b squared is should really be the same thing as c squared. So at the next page, if you look at the very bottom, it says a blank occurs when a figure is moved from one part of the Cartesian plane to another without changing size or shape. And that is called a transformation. A transformation. And one type of transformation is a rotation. So rotation is performed when a figure is rotated within the Cartesian plane. So here you see some examples of rotations. So if you look at this triangle here, this is rotated to here and here and here. And then this rectangle is rotated from here to here and here to here. And that's how you create the shape. So number 1 wants to know if ABCD is a rectangle, why or why not. So again, we just have to find our slopes. So we're going to rise 1, 2, 3, and run 3. So that's 3 over negative 3. The slope here is negative 1. I'm going to do the same thing for DC, because I first got to make sure they're the same. So 1, 2, 3, 1, 2, 3. So 3 over negative 3 is negative 1. So those two slopes are the same. That's a good sign. Then I've got to find the slopes of AD and BC, and they need to be opposite reciprocals. So 1, 2, 3, 1, 2, 3. 3 over 3 is positive 1. And 1, 2, 3, 1, 2, 3. 3 over 3 is positive 1. So since this slope and this slope are opposite reciprocals, yes, this is a rectangle. Number 2 or 3 wants to know is ABC a right triangle? So we need to find our slope here, because if it's a right triangle, then these two slopes should be perpendicular. They should make a 90-degree angle, or in other words, they should be opposite reciprocals. So we're going to find the slope of each one. So starting with BC, our slope, we have to rise 1, 2, 3, 4, 5, 6, 7, 8, 9. And we're going to run 1, 2, 3. So the slope is 9 over 3, which is just 3 over 1. And then for BA, our slope is rise 3 and run 1, 2, 3, 4, 5, 6, 7, 8, 9. And since I was going to the left, it's negative, so that slope is negative 1/3. And these two slopes are opposite reciprocals, so yes, it is a right triangle. So number 5 wants to know, is this a square? Well, if it's a square, then this distance, and this distance, and this distance, and this distance should be the same. So theoretically, what I need to do is use the distance formula to figure out what those 4 distances are. But I can actually use my slope formula to help me out. By finding my slope, if they're the same numbers, even though the signs are different, then they are in fact going to be the same length. So to find my slope, I'm just going to rise 1, 2, 3, 4, 5 and run 1. So this is 5 over 1. From D to A, I rise 1 and I run 1, 2, 3, 4, 5. For D to C, I rise 1, 2, 3, 4, 5, run 1. And for C to B, I rise 1 and run 1, 2, 3, 4, 5. So since all of these numbers that it gave me were 1 and 5, regardless of signs, yes, it's a square. Number 7, if you translate the following triangle 4 units to the right and 3 units down, what quadrant will it be in? Well, first of all, we need to review a couple things. Our quadrants are 1, 2, 3, and 4. So if I'm going to move this 4 units right and 3 units down, that means I'm moving every point. 4 units to the right and 3 units down. 4 units to the right and 3 units down. And lastly, 4 units to the right and 3 units down. So it would be here, and that triangle is in quadrant 4. So that would be our answer. And lastly, number 9, in the design below, which polygon has been rotated? And there can be multiple answers here. So we're looking at the gray triangle, or the white rectangle, or the black square. Well, rotated means that they're twisted, they're moved around, and actually all of these have been, so D is our correct answer.